All right, so let's get started on 7.6. So we have a double, it's not really a double lesson because honestly this could have been one lesson. It's about common logs and the common log and the natural log. That's all this is about. Okay, so first let's break it down into what we already know. Oh my gosh, I don't know why that happened. All right, so, okay. So throw back to when we learned what this meant. Log base 7 of x. What does this even mean? All right, think to yourself before I'm going to call on someone. I want you to, like, remember what we did 2 days ago. Maya? Sure. Cool. All right, log base 7 of x. What does this mean? Like, what does this mean? Yes. Exactly. Logs find exponents. Logarithms find exponents. So when I say log base 7 of x, what I'm trying to find is what exponent 7 to what exponent will equal x. 7 to what exponent equals x. Okay, and so that was a base 7. What if I have a different base? Like, what if I have log base 3 of 2? What would this be? 3 to the y equals 2. So it's not 3 times y, it's 3 to the y exponent equals 2. So that's one thing we missed on our quiz, was understanding how to rewrite logarithms in terms of an exponential. 3 to the y power equals 2. Okay, so I don't know what exponent this would be, but it would definitely be less than 1. Because 3 to the 1 power is 3. All right. So that was a base 3. What if I have something like log base square root 2 of 5? Like, what the heck does that even mean? Square root 2 to the y power equals 5. We just rewrite. It's like the little circle. We start with the base, go to the exponent, and then we go to what it's equal to. So this is a base of square root 2. What if I have something maybe a little easier, like log base 10 of x equals 3? Like, how would I rewrite this one? Let's take a gamble. 10 to the third power equals x. So what's 10 cubed? Yeah, it's 1,000. Okay, so whenever you see log, oh my gosh, I don't know why that happened. Log base 10 of x, any number. Log base 10 is literally your common log. So if you just see like log of 4, okay, so if there's not a logarithm written there and you see log, like a timber log, a wood log, 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 and there's no base written, you have to assume it's 10. That's the common log. That's the one we're going to assume. All right, if something's so common, like you don't even think about it, you don't write it, you might get lazy. Here, that's kind of what happened with math. The common log is just base 10. All right, so that's a little intro of what we're going to be learning. So the common log, we're like halfway through. Common log is base 10. Logarithms of base 10 are called common logs. They're usually written without the subscript 10. On scientific and graphing calculators, the key log is the common logarithm key. So if you look at your calculator, you're going to see the log key, and whenever you use it, that's when you're using 10 as your base. All right, so it's time. Just a friendly reminder, because I know it is Monday. Phones should be put away. Should be on your desk. Shouldn't be on your lap. Just totally put them away. Give you a little like passy pass. Put them in your bag. Put them totally away. I don't want to see them on your desk. If I see them on your desk, take away a point for phone, because it should be so far put away. All right, just common reminder. So log base 10 of x is written as log x. Oh my god, where'd the base go? Oh, it's gone because it's the common one. What's an example of something that's common that like we don't even think about it? We don't write it. We have an example from real life? No? So here, everyone like knows. Okay, here's an example. Everyone knows your left and right. So on the count of 3, everyone raise your left hand. 1, 2, 3, left. Okay, how'd you know it was your left? Like, there's no sign up here saying that. Because you know this. It's common. Everyone decided this if you turn that direction, right, that's to the left. We all decided that's left. We all have like a common knowledge that that is left. The same way everyone has a common knowledge that if there's not a base written, it's going to be 10. All right, use your calculator to find the following values, rounded to the nearest 10,000. So I asked you to get out your calculator earlier to find the log key. Now we're going to be using it to find the following values to the nearest 10,000. So you should be bringing your calculator to class every day. You should have it. You ready? Okay, 2 people. You're done, sit up. All right. So if you type in log of 6, what do you get? So I want it to the nearest 10,000th as well. Log base 6, what do I get? So do you see the log key on your calculator? Yeah. Okay, so literally push the log key and then put in 6 and then push enter. I can pull it up if you want me to.
No, that doesn't work.
Oh, is it like...
Is it a control log? Well, then when it's control log.
I'll pull up my calculator. Let's see. All right, so I'm showing you this in class, which means 100% I'm expecting you to follow along. This is me teaching you how to use your calculator. If you ask me this on a test, I will not answer. You have to know how to use your calculator.
The log button.
Huh?
The log button.
Correct, that is what I said. All right, so I'll just go to home, I'll go to calculate, and then let's see, where is, oh, I need to move this over. Okay, that's not what I wanted. So I was trying to show the log. Oh, I can actually see it now. You push control, log, oh my gosh, clear. Delete, go back. Why is this so slow? All right, calculate, clear. So you push control, LOG. You do, because otherwise you're doing 10 to the power of x. So if I don't put in a base, it assumes it's 10. So if I just push the 10 to the x key, I get 10 to whatever power. I don't want that. Delete, delete, delete. Okay, I push control, the blue button, and then I'll get to what the blue number is above 10 to the x key. Can you guys see where I pushed my buttons? All right.
So you like put in the 10?
No, so it's a gray box, which means I can leave it blank. Because your calculator is, like, this is why the Inspire is better than the 84 and the 83. It's one of the many reasons. The 83 and 84 could only calculate logarithms of either base 10 or the natural log, which is base e. Your calculator can calculate the logarithms for any number for having any base. So it's really powerful because then that saves you a lot of time. So if I don't type in 10 as the base, I just put in that 6, it assumes it's 10. So if I push enter, look what happens. It plugs it in for me because it's the common log. If you don't have the logarithm written as your base, sorry, if you don't have 10 written as your base in your logarithm, it'll assume it's 10.
Then how do you just solve it if you don't need to have the log?
I left it blank and the calculator automatically plugs it in. If I don't fill it in, it's going to think it's 10.
Like when when the problem doesn't have the 10 underneath.
Right, so that's, you would put it in and that is the common log. Whenever you don't have the 10 written underneath and you have LOG, that is the common log. That is your base 10. When it's not written, it will be base 10.
So it's like always base 10?
As long as it's LOG. As long as it literally says log. And I'm being very specific about this because, well, you'll see in about 10 minutes why. All right, let's go back. So I see I need to round this to nearest 10,000th place. So let's review 10,000th place. Is that here? What is this? 10th. What's this place? 100th. What about that? 1000th. I don't know if that's how you spell 1000th. Whatever, you understand what I mean. And then here, this would be 10,000th to 10,000th place. So I literally want, how many decimal places after the period? How many places?
4.
4. Okay, so if I round my answer, look at your calculator, what do I round it to? Is equal to 0.77. What should my numbers be? All right, I'm really glad we're like super awake, pay attention. If I look down at your calculator and I want 4 decimal places, what is it, 0.77? I'll do 82, right? You round up? 7782, yep, because we have that 5.
Yeah, the 5 makes
Just normal rules of rounding. If you see a 5, you gotta round up. All right, so make sure to just silence your phone. Just silence it. Okay. All right, let's try the next one, log 0.35. All right, plug it in. Let's see what we get. Plug it in. What do we get? Negative 0.4559. Awesome.
Yeah.
Yep. All right. So we practice plugging in numbers. Decibels is a measure of loudness of sounds and is represented by the following formula. L equals 10 times log of L over M. What is a sound? And L is the number of decibels. So you guys have heard of decibels before? Like a complete silence room is like 0 decibels. Whispering's like 10, maybe 15. Lawnmowers maybe like 60 to 90. A jet taking off is 120, 130. When you have hearing loss if you're at something that's over 120 decibels. So a rock concert, if you ever guys, actually any concert, have you ever gone to a concert and you leave and like your ears are ringing? Yeah, that's you're damaging your hearing. So little by little you are like losing your hearing. So that happens if there's too much intensity, too much decibels. It's ruining your ears. Fun fact, do you guys know what the Saturn V is?
What?
The Saturn V, it's a rocket that took the Apollo missions. The missions that went to the moon with NASA. So Saturn V rocket was 215 decibels. Something like that. 215 I think. And it's so loud that literally the sound waves would like cause a fire up to like 2 miles away. So that's why if you ever watch a space shuttle launch, you'll see as it's launching the space shuttle or the Saturn rocket, literally they are pumping millions of gallons of water to like soak, I guess, absorb the sound. So that's something cool. That's why if you like go underwater, it will like muffle your sound. Anyway, let's keep going. Sound intensity of a jet engine, whose loudness is 125 decibels. So I was right. Jet engine's about 100 decibels. 120. If M equals 1. Okay, so what we're trying to solve is, what is the sound intensity? Sound intensity is I. I'm trying to get I by itself. Okay, so let's rewrite. The loudness is 125 decibels. That's my L. My minimum intensity audible, okay, so my M's 1. We're trying to solve for I. I have L is equal to 10 times log of L over M. So notice that, what's the base here? Like, did we not write it? What's the base here? 10, because it's the common log. Okay, so I'm going to plug in all my numbers. So I have 125 equals 10 times log of, let's see, I over M. So I over 1, what's I over 1? I divided by 1 is, it's just I. All right, so divide each side by 10. I have 12.5 is log of I. How would I go about solving this?
Wait,
Isn't it not like
divide by log.
So, okay, step by step, when I inserted I divided by 1, that was equal to I. Divide each side by 10 here. I get 12.5 is log I. Secretly, there's no base written, but we know it's 10. So, if I rewrite in terms of what we already know, 10 to 12.5 equals I. So if you go back to your calculator and put 10 to the 12.5, so let's see how to do that. So you just push the 10 to the X key. You just push 10 to the X key.
What?
Oh my gosh, come on.
It's a 10 in the X part of this X.
It's the bottom left corner. It's what you pushed with log, but you don't push control first. So 10 to the 12, 0.5. Enter. Oh my god, it gives me this e. What does e mean? It means times 10 to the power of. That's what e means. So here, I want times 10 to the 12th power. So I'll show you what that is. So literally, the intensity is going to be 3.2 times 10 to the 12th power. Yeah, scientific notation. So you guys have, yeah, they do this in freshman year, so everyone knows this. All right, solving logarithmic equations, taking logarithm of each side, more or less. All right, so we're ready to move on? So let's see. If I want to solve 6 to the x equals 42, I can't just divide by 6 because I have this exponent. If I take log of both sides, I would ideally like to get rid of the 6. Like,
What does that mean?
All right, so we talked about how to solve exponential equations. Now we're going to solve logarithmic. So right now, there's no way for you to solve this problem. So I'm proposing a new way of doing it. So if I take log base 6 of both sides, what happens on the left side with this portion? Well, first I want to move the exponent to the front. So this is what we did last time. We talked about the properties of logarithms. And the power property allows me to move the x out front. So then I have I have x times log base 6 of 6 equals log base 6 of 42.
You can take out the logs.
So, well, I put the logs back. I put the logs in there. So there's something tricky happening here. Can I simplify log base 6 of 6? It's 1. So we've talked about this before. So if I take log base 6 of 6 and like go to solve for it, 6 to the y equals 6. This whole thing can be replaced with 1. If it's the same two numbers, it will be 1. So if I have log of 17 of 17, that's equal to 1. So I think this is section 7.2. 7.3, we went through, like, we found this to be true. We went through it ourselves.
So it's stuff against
Not quite. So we rewrote it. Now I want to, if I put in log base 6 of 42 in your calculator, you can solve this. So log base 6 of 42. So control 10 to the x. All right, so log base 6, so you can fill in what base we want. We want the base to be 6. And then of 42. So you just fill this in on your calculator, push enter, and it gives you the answer. It's beautiful. Your calculator does the whole thing for you.
How many numbers do you want to start 4 after this?
So the nearest 10,000th is 4 after the decimal place. So what this looks like is x is equal to 2.0860. That way I have 4 decimal places because it said to the nearest 10,000th. Yeah, you have to write the last 0 because I said to the nearest 10,000th. So you have to have a thing, a digit, in the 10,000th place. All right, let's try to solve the next one. How would I approach this one? So first off, all right, so I'm going to take log of both sides. Question is, what should the log base be?
5.
5. What was your question? How do you figure that? How do you know I should have a base of 5? Because that's the base for the exponent I'm trying to solve for. Right? I see my x right here. I have a base of 5, so if I take log base 5 on both sides, just left with the exponent. Using properties of logarithms, I can pull out that exponent, and then I have log base 5 of 5 is equal to log base 5 of 62. So I'm hoping you can see Like everything builds on each other. So we're using the definition of a logarithm, like literally log base 5 of 5, that's 1. Using properties of logarithms by putting the power, moving it to the front. So this whole thing is just equal to 1. So I have x is equal to log base 5 of 62. Let's practice plugging that into our calculator again. Round to nearest 10,000th place, what do we get? Alright, so let's practice plugging in. Log base 5 of 62. Push control. Log base 5 of 62. Push enter. 2.5643. Exactly, because we went to the fourth. Yep. So 2.5643. Awesome. Okay, so the change of base formula, so I'm going to show you what this is. This is literally until the Inspire came out, this is how you would have to do it. Because the 83, 84, they would not do these bases for you. They would not do base 5, base 6, base 17. They would only do base 10 and base E. That's it. So change of base formula allows you to write logarithmic expression in another base. So it's useful for bases other than those on your calculator keyboard. So you don't have to use this anymore because you have your Inspire calculator, but I just want to show you what it is because I have to. It's part of the Algebra 2 curriculum. Then you'll get an understanding of like literally what your calculator is doing for you. So if you have log some base of a number, you take log base b of the original over old base. So it's, I'll just put like OG number. The OG number over the OG base, the original base. And what's helpful is if you have it be log base 10, the common log, every calculator can solve for that. So we're gonna write each of these as a common, like using the common log. So remember, it's log of the original number. So the original number is 8 over log of the original base. The original base is 6. If I don't write the base here, what does it mean? 10. Okay. So if you put this in your calculator, log 8 over log 6.
It would be log base 8.
Because secretly the base is 10 here.
Oh, in our calculator we have to write log base 10.
Nope. So control log. So I want 8 divided by. Do I want to put parentheses around the whole thing? Yeah.
You're not putting 10 at the base?
I don't have to because the calculator knows that's what I want.
Okay.
Log of 6. So I'm being like super careful with my parentheses. Oops, that's not what I want. Oh my god, that's not what I want. Alright, so if I push enter, let's see what I get. That's, why is it, oh man, I put multiply, I want to divide. What am I doing?
Oh, how do you...
Ugh, alright. Control, let's see. 8, what? No, go back. This is a lot easier if you just use your fingers and a real keypad.
I got 0.90309.
There, this is what it's supposed to be. It's just hard to plug in. 1.1606. Because you want it to be division, huh?
Oh, wait, I just got it wrong because I plugged the wrong number in.
Oh, yeah, probably. 1.1606. All right, let's try the next one. Does it say T for you?
Yeah.
Let's make that be 140. I don't know why that happened. So we take log of the original number. So I have log base 10 of 140 over log base 10 of the old base, which was 5. Plug that into your calculator. Okay. That's fine. I'm gonna keep going though. So. All right. So, what? Didn't I like cut some of these problems for you? I think I did. Yeah, I like cut some of these problems after I. So this is because we're doing 7.6 and 7.7 today. 7.6 is common log. 7.7 is natural log. So I've covered common log. Now we'll do natural log. Give you guys a second. What? Yes. All right, so common log's base 10, base e, and natural log. All right, like the numbers pi and square root 2, the number e is irrational, has a value of 2.718, so we covered this already, right? That was like 7.13 weeks ago. This is like the first thing we talked about. Remember when we did, like your uncle came and was like giving you money? Remember that day?
It was like a penny.
Yep, doubling that. So we found like exponential functions. We talked about what the value of e was. E is the natural, it's like the natural base. It's the natural base function. So shorthand, instead of writing log base e, we can write ln. So if you see ln, that's the natural log. This is why I was being so specific with saying if you see log alone, because ln means log of base e. But when I say, ln of 4, well, that's a log without a base, but it's ln, not log. All right, so just so you know, a couple things. E, it stands for Euler. He's a famous mathematician. I'm sure you guys heard of him in geometry. If you ever take calculus, you'll hear of him again. If you ever take anything with astrophysics, you'll hear of him again. Anything with more math, you'll hear of him again. He was brilliant. He was absolutely brilliant. He came up with so much stuff. Whatever. All right. So, a little reminder. Log base 10 of x, we can just write that as log of x. If I have log base e of x, I can write this as ln of x. ln, natural log. You're literally taking log with the base of e. Okay. So an example of how to write that is if I have log base e of 5, that's the same thing as saying ln of 5. If I see ln of 7, that's the same thing as saying log base e of 7. So we must be familiar going back and forth. Zoom out just a tad. All right, equations commonly seen and used. So keep in mind like log base 5 of x, let's see. Log base 5 of like 5 to the x power. If I have that, I'm just left with x. Same thing if I have e to the ln of x, the e and the ln cancel each other out and I'm left with x. If I'm taking natural log of e to the x, that cancels out, I'm left with x. Whenever you have ln times e or e to the ln of some number, they like cancel each other out. Okay, so let's try some of these problems. All right. So example 1, write each exponential expression in logarithmic form. So I just want to write it as a log. That's it. I'm not evaluating. I'm just rewriting as a log. Do you have any idea how to rewrite, I don't know, example A? So we're thinking back to, yes, Maya? All right, so another way of saying that is ln of 23 equals x. All right, so if you're confused, literally just pause. So to write it in log form, it's log of the base. Let's see, log base result equals exponent. So here was my exponent, so I put it on the equal sign, equal side. E was my base, and 23 was the answer, was the result. E to the x power was 23. Okay, let's try part B. Let's try example 1B. So I just want to rewrite this in logarithmic form. So I have log base E, because that was my base, of the result x equals 4. Or another way we could say, instead of saying log base E, I can write ln of x equals 4. Good. Okay. You had to answer it up.
Does it matter which one you...
I would prefer, if you see log base E, I want you to write ln. I would prefer that. If you use 2 already? Yeah, I mean, you can use more than 2. I just mark down every time. You want to know how many you've used?
I think I used 2. I think I used 1 last week. I can't remember. That's just where
Maybe 2.
okay. I'll take it up there.
Alright, so let's now write each logarithm in exponential form. Do you have questions over this so far? Yeah, ln. Do you have questions over this so far? Okay. So I want to make sure I pause for a second. It's like we're using a lot of the things from previous lessons. So you have to be solid with those lessons in order to really understand what we're doing here. Okay, so how can I rewrite this in terms of an exponential? Do we know? Do you have an idea? I've already asked you. Put your phone on silent. Go ahead and wake up. Okay, so this is the same thing as saying log base E of x is 1.2528. So E to the 1.2528 is equal to x. You're doing, so this is nothing new. This is just exactly what we have been doing already. I want you to try part B, and then I'm going to call on someone. The question?
Oh.
So, right, ln of x is the same thing as log base E of x. And then you just do the little curly Q. Base to the exponent is result. Okay. So let's try the next one. I'm just going to rewrite this in terms of, let's see, log base E of 25 equals x. Tamar, you want to try?
E to the 25 equals x.
Close. E to the x equals 25. All right, you start at the base, go past the equal sign to the exponent, and then you come back to the result. All right, surprise, surprise, properties of logarithms can also apply to natural logs. So example A, I want to write this as a single logarithm. This is a review of what we did Thursday in class. 4 times ln of 3 minus ln of 6. Okay, so first thing we should do, what should I do? I'm wanting to condense this. I could do that, but what about, okay, turn back to 7.5. Look at 7.5. Think about what properties I'm going to be using. What properties could I use?
Quotient.
I will be using quotient rule, exactly. First, I'm going to use power property. So I'm going to be using the power property, meaning now I'll have ln of 3 to the 4th minus ln of 6, and then Gabby said we can use quotient. Alright, so it's first over second, right? When you're subtracting, the one on top was the one on left. So I have ln of 3 to the 4th over 6. So that's the same thing as saying ln of 81 over 6. Can I simplify this at all? Is there a common term that goes into 6 and 81? Yeah, 3. So 81 divided by 3 is 27. 6 divided by 3? 2, and that's it. This is it. I wrote it as a single logarithm. I think this is hard because we're like... Let's see. So power, then we do quotient, then we simplify. So 81 divided by 3, 6 divided by 3. Let's try part B. Okay. What'd you do the first part?
You make 2 the exponent in the front, and it's ln 3 to the power of 2.
Yeah, ln of 3 squared. Am I good to move over? Anyone need it still? Okay. So I'll take the 2 and rise it here. So first I'm doing power. Okay, yeah. So make sure I didn't like miss anything. Okay, so 3 squared plus ln of 4 plus ln of y. So everything is, all the logs are being added, which means all of the inside part is going to be multiplied together. When you see addition of logarithms with the same base, you can combine them by multiplying all of the insides together. So this is the same thing as saying ln of 3 squared times 4 times y. Ln of 9 times 4 times y. Exactly. Ln of 36y. What's 3 squared? Yep, it's 9. Awesome. Good. Doing a little more time? Okay. Okay, so equations, we're not doing inequalities. Equations with e and ln. Solving equations with natural logarithms is made easier because when you take natural log of e, the answer is just 1. So solve round to the nearest 10,000th place. Okay, so if I want to solve for x here. The first thing I want to do is get the exponential by itself. How do I get this term by itself? Good. Let's subtract 4 on both sides. So I have 3 to the 3 times e to the negative 2 is 6. Okay. Now I have this pesky coefficient. Divide by 3. Good. E to the negative 2x is equal to 2. Okay, so remember how we were working with common logs and we were trying to solve an equation? I want to solve for x, but it's in the exponent. If I'm solving for something in the exponent, do we have an idea of what we could do? maybe turn. It's like on the first page of 7.6. It's in bold. Solving logarithmic equations. What do you do? First page 7.6. What do you? Huh? Well, it'd be hard to write it in logarithmic form. Because I want to solve. I want to get like x by itself. So when I'm solving logarithmic functions, what should I do? Take the logarithm. Take the logarithm of both sides. What should my base be? Logarithmic with base what? Yeah, exactly, with base e. So I'm going to take log of base e on both sides. So I'm taking ln of both sides because that's natural log. That's log base e. So I already know, so I'll just rewrite this, all right? So ln of e to negative 2x is equal ln of 2. Let's see. I know that if I would just have ln of e, that is equal to 1. So do I know a property? Could I move the exponent in front? How did I do this? Yes, Maya? Yeah, I move it to the front. This is the power property of logarithms. So I have negative 2x times, let's see, ln of e is just 1 is equal to ln of 2.
ln e, that equals log base 10, and that also equals
Not log base 10. ln of e is, ln of e is the same thing as saying log base e of e. And we know if I have a log of base with that same number, it's just going to be 1. So I have negative 2x is equal to ln of 2. So if I want to solve for x, divide by negative 2 on both sides. ln of 2 over negative 2. That's going to be equal to negative 0.3466. So just like round to the nearest 10,000 place.
Since it's ln, this is log, how would you put it?
So you would write it this way. Log base e of e, or there is a natural log. So notice on the, so right here on the very left side, there's ln.
Oh, okay, so
Yeah. So control, it has its own natural log of 2 divided by negative 2. So negative 0.3466, I round up. Awesome. So let's try the next one. The next one's similar. Think about, I want to get, like my idea is get x by itself. So I have to work myself from outside in, right? Get rid of any other terms that are being added or subtracted, get rid of any coefficients, take log of both sides, get x by itself. So do we know what we should start with on the right side? Jenna, do you know? What's the first thing I should do? Exactly. Add 12 on both sides. So I have 3 times e to the 4x is equal to 27. All right, Miles, what do you think we should do next? Divide by 3. E to the 4x equals 9. Okay, I want to solve for x. I want to solve for my exponent. Get rid of, my base e. So take ln of both sides. So I'll rewrite this as ln of e to the 4x equals ln of 9. Yeah, I'll move the exponent out front. So I have 4x times ln of e equals ln of 9. Now this whole thing is just 1, so 4x equals ln of 9. Exactly, divide by 4. So x is just ln of 9 over 4.
That one side, why can you cross both ln's off? Oh,
Uh,
this one has the e. Yeah.
Well, right, I can't just cross out ln. It's kind of like if you see a minus sign on both sides of the equation, you can't just like cross out the minus signs. Like it's an operation.
Like add, right?
Oh, if I was trying to solve for what the inside portion is, I see what you mean. Yeah. So I could set the inside portions equal. It's not crossing them out. All right, so plug this into your calculator. You will get 0.5493. Cool. So this is difficult. I know this is difficult. Like, but we can do it. We can persevere together. Like, I'm proud of you guys for not like seeing this and giving up. Like, this is good. It's good. All right, let's try to solve the next one. All right, so this is a little harder because I have an ln and I want to solve for x. It's more or less like doing like the opposite of what we did last time. Okay, so first let's get the ln by itself. Divide both sides by 2. So I have ln of 5x equals 3. How would I like get rid of an ln? How do I get rid of a natural log? Remember, because if I have a base of e, I could take natural log on both sides. If I have a natural log, I could not multiply it by e. I'm going to take each side, like it's not raise each side to the power of e, but literally I'm going to put e to the power of each side. Yeah. Remember how last time if I had my e as my base, I would take ln of both sides? Here, if I have ln as one of my like sides, I'll have each side be like e to the power of the side. And then, oh my god, guess what happens right here? E to the ln power, like they cancel each other out and I'm left with the 5x.
So it's 5x equals e to 2.
Yep, so x equals, yep, so e to the third divided by 5. Do you guys know where your e button is on your calculator? Okay, so if you do, you see where it says e to the x, just push that. So it's the very left side, like halfway down. Yep, so I just put 3 in as my power, and then I can move over a side, divide by 5. Let's see what I get. 4.01711. Okay, let's see. So I went to the nearest 10,000th. 4.0171. Yeah, that's it. All right, so it's clearly going to take some practice. How do I, okay, so ln button. If you go to where if you push control and then push the e to the x, it goes to the blue that's right above it, which is the ln.
Wait, so control.
Yep, because it goes to the little like ln that's above it. All right. So this next part would go better with like 7.8. Have you guys heard of APERT before? Okay. So this is another way to find continuous interest. So I've gone, like I'll give you this equation on your test, just like I'll give you the other equation. So continuous interest is, we did compounding interest. So it's like, okay, so we found how much money you would earn if the bank paid you every month, if they paid you every week, right? The compounding, it's the n. So we went over, well, I have more room here. Okay. So we went over compounding interest. So compounding interest is A equals P times 1 plus R over N, all to the NT. Okay, so what happens if, not just like once a year, right? So N is the number of times you compound, N is the number of times. What if I don't even compound every month? If it's like every day? How about every minute? Every second? What if I'm literally every single second we're recalculating what your total is? But let's go further than that. Like whatever, like microsecond. Let's just be like flat out, just like continuous. Like every single microsecond of a microsecond, we're constantly accruing interest. We could say that's continuous. And so what happens if we have n be infinity, right? So it's like, it's not even like a million times per year. It's like infinite number of times per year. It's like every single microsecond. If I change the n to like, to be infinity, this whole thing here goes to a equals p to the ERT. This portion right here that I'm highlighting is literally e to the r. It goes to your base e. Yeah. Yeah, you don't really whatever. A equals a part. A equals p ERT. P is the principal, how much you started with. E is just, exponents, 2.7, whatever. You have it in your calculator. R is the rate, written in hundredths, and T is time. Yarden, wake up. T is time. So, I believe on the test it was like Tamar buying a car, or someone. Maybe like Lily buying a car, I forget. Or on the quiz. Continuous interest. So, suppose you deposit $700 into account, paying 3% annual interest compounded continuously. This is how you know to use APRS. It says continuously. It doesn't say monthly. Monthly would be the other one. It doesn't say daily, weekly, quarterly. That would be the other one. Continuously. What is your balance in 8 years? So, A equals, let's see, my principal is 700 times e to the, let's see, my rate's 3%, so how would I write this? I moved the decimal place over 2, so 0.03. And my time is 8 years, so 0.03 times 8. Should probably write this out. A, we don't know. P is 700. R is 3%.
But wait, why is there an E?
Because it's continuous. It's not being compounded every week, every month. It's literally every single instant. So here's a hint. Like, my student loans are continuously compounded, which means I could have checked my balance at the beginning of the class, and it would have changed by the end of class. It would have went up at least a couple cents. Yep. So this is like one reason why it's really important for you guys to understand this, because you will have to deal with this. If you buy a house or a car, like save money, retirement accounts, this is where it comes into play. So this is 889.87. So notice I rounded to 2 places because this is literally money. Money you always round to 2 places.
So you just plug that into your calculator?
Yep, you just plug this in. Do we want to see how?
Yeah.
Let's do it.
You use it with the compound, right?
Yeah, if it was like monthly, you'd use compound. So I have 700 times, let's see, I don't want the control button. I just want the E button. I don't know why I did that. No, go back, damn it. This thing, okay. So E to the, I have 0.03 times 8. And enter, there we go, 889.874. I rounded 2 places after the digit because it's money. Yarden, please wake up. Cool. I think there's just, all right. How long would it take your account to reach $1,200? This one's a little more tricky.
So A equals 1,200.
So I want 1,200 is how much I end with.
So
That's how much I end. Principal is how much I start with, so that's 700. My rate's still 0.03, but I don't know my time. What's wrong? So this would be like a bonus question. Having to solve for t, having to solve for the time. Okay, so how would I actually like go about solving for this exponent? Give you a clue, it's what we were just working on, the previous problem. How would I get the time by itself? First step is to divide by 700 on both sides. 12 over 7 is equal to e to the 0.03t. And then let's see the previous page, example 4a. Like, how did I get the exponent by itself? ln. Take ln of both sides. ln both sides. Bless you. So I have ln of 12 over 7 is equal to 0.03t. If I take ln of both sides, this portion cancels out and I'm just left with the exponent, which is what I put over here.
Wait, so if it's ln, both ln cancels out, it will be
Well,
over 7 equals 0.
No, the ln's don't cancel out though.
Just
The lne, just the right lne.
Then how?
So, if I want to solve for time, divide by 0.03 on both sides, time is ln of 12 over 7, divide by 0.03. So as I said, this is like a trickier problem. This would be like a bonus, more or less, on your test. This would be a great bonus question. So I can round up to about 18 years. I think the part C is a little bit easier. It's a little bit easier, and this is also, I forget, what is it, 1 through 5, I think? 1 through 8.
So are you finding
How much would be deposited? So we're looking for P, the principal. This would be your balance. P times E to the, well, we still have the same rate. 12 years. So this portion right here, if you plugged into your calculator, 1.433 times P is equal to 1500. So you just divide both sides by your 1.433. And you'd see that you would have had to start out with $1,046.51.
wait, where did you go?
So if I would put in e to the 0.3 times 12, that's what this is right here.
Oh, okay.
Yeah.
So we don't have to like once you multiply it's gone.
Yeah. Because it's a number. It's just 2.7, blah, blah, blah. Cool. All right, cool. So tomorrow we're going to finish 7.8. I'll give you a practice test. Wednesday we'll go over the practice test. Your test is Thursday.